In this video, we will discuss the problem change bits. The problem says that we'll be given a number n and we have to do two tasks. The first task is to generate a new number from this number n by changing the zeros in the binary representation of n to 1. So let us suppose that we have been given the number n is equal to 8. So what is the binary representation of 8? Its binary representation is 1 0 0 and 0, I think, because this is 1 2 4 and 8, right? Now if the binary representation of 8 is there, so we have to mark this as 1, this also we have to mark as 1, this also we have to mark as 1, and this one will remain as 1. So what is the new number now? The number is 1 2 4 and 8. So if we add these values up, so we can see that we are getting the new number as 15. That is, this is the basically the representation of 15. So when we get the representation 15, so from 15 we can say that we have to subtract 8 as well, because we have to find the difference. So it comes out to be 7. So we can see here that the number is 15, the new number is 15, and the difference is coming out to be 7. So how can we do it? So first of all, we need to count the number of bits. Okay, so we need to count the number of bits in the number. So for that, we can maybe use something like log n plus 1. Or what we can do is we can simply iterate through the number and count the number of bits. So let us check this out first of all, like how we can count the number of bits. So the first process is log 2n plus 1, but we will do it in a better manner. So what we can say is, like, suppose that the number is 8. Okay, so I will run until the number is greater than 0. So currently I can say that the currently number is 8, so I can store it in a temp. So I'll say that temp is equal to 8. Then what I'll do is, every time if the temp is greater than 8, then every time I'll keep on dividing it by 2. So what will happen, I will say that okay, count becomes 1, and now I I have divided, so it becomes 4. Then I can see still the number is greater than 0, so I'll divide it by 2 again, and I'll mark the count as 2. Then I'll divide it by 1, like 2 again, so it becomes what? It becomes 1. The count increases, changes to 3. After that, what happens in this part, we can observe that still the number is greater than 0, so again divide it by 2, so the count changes to 4. Now if my count changes to 4, so I can say that what I will do is, I will say that I'll generate the change number will be nothing but 2 to the power 4 minus 1. Why? Let us try and see. So if I have this number, okay, if I have this number like c is equal to 4, so 2 to the power 4 is nothing but what? It is nothing but 16 actually, if you will see. So 2 to the power 4 is nothing but 16, and if I do 16 minus 1, so I'll get 15, and that is the number that I was expecting here. Okay, so that is the change number, because 15 is what? 15 is nothing but 1 1 1 and 1, as we discussed, because 1 2 4 and 8. So this is how we'll get the number. You do what? You do 2 to the power 2 to the power count minus 1 to get the change number. Okay, after you have got the change number, so basically you can return this thing, the difference between the change number and the n. We can directly find it out. Now let us, like, this is very important concept in bit manipulation, then that whenever you have 2 to the power c minus 1, so you get this thing. So suppose if you had 8, if you have a number 8, so what is 8? 8 is nothing but 1 0 and 0. If I like 1 0 0, if I subtract 1 from it, so actually I'll get 7, and 7 is what? 1 1 1 and 1. So you can see these bits, all these bits get set, right? So basically in this case, you have to observe this thing, that actually here my number is not given to me as a, like here my number is given to me as 8. So what I need to do is, I need to generate one greater than it. Basically I need to do what? I need to have 16, because if I do 16 minus 1, like, then in that case what happens, I'll get a number which will have all the bits as set till that much time. You can see here, right? You can see that if I do 16 minus 1, that will be 15, right? 16 if I get, right, 16 is nothing but 2 to the power 4, that I'll get by counting the number of bits. 1 2 3 and 4 is with the bits, so 2 to the power 4 is what I'll get. 2 to the power 4 minus 1 will give me this thing. So that is how I'm doing it. Now let us check it for the another example. Suppose we have been given 6. So we will first of all store inside the temp 6, and then what we'll do is, we'll mark the count initially as 0, then I divide it by 2, so it becomes 3, so the count becomes 1. Then I divide it by 2 again, so it becomes 1, and the count becomes 2. Then I divide it by 2 again, so it becomes what? It becomes 3. So the count here is 3. So I will say that 2 to the power 3, 2 to the power 3 minus 1 is what? 2 to the power 3 is 8. 8 minus 1 will give me what? It will give me 7, and actually that is the number that I expected. Why is that so? Because 2 to the power 3 will be what? 2 to the power 3 will be like this: 1 0 0 and 0, because 1 2 4 and 8, you can see it. But basically I wanted what? I have a representation of 6. 6 is nothing but 1 0 0. If I subtract, like if this is the representation of 8, then I subtract 1 from it, so I'll get 7, and 7 is 1 1 1. So that is how I'm getting all the bits as set till that point of time. That is why I counted the number of bits that are there in the number, and -1 if I do, so I'll get 111, basically an odd number which is having all the bits as set. Okay, for this number of bits, right? So that is what I'm doing. So let us try and implement this code. Basically the number of, since we are iterating on the bits only, so the complexity will be log n only, and let us try and see what will happen. So first of all, I'll do what I will have, like we need to declare a vector. So we can say that we have a vector of int, let's say we have a vector of int, let's say answer, and then what we will do is we'll have a temp is initialized to n initially, and then I need to have a counter. So let's say I make a counter initially as 0 to count the number of bits that are there in this number temp, like basically in this number n. So if the temp is greater than 0, till then I'll keep on dividing it by 2. So we can say that what we will do is for this, if the bit, like if the number is still greater than 0, I'll first of all increase the count, then I'll say that temp is equal to 1. Okay, so basically I'll do what I'll basically decrement, I'll basically decrement its value by 1. Okay, then once I've done with this part, so what do I need to do? I need to store it. So I'll say that answer dot push back. So in the answer, first of all, I'll push back what? I'll push back, like first of all I need to generate the number. So I can say that int new number is equal to nothing but 2 to the power, like it will be nothing but 1. Like I can left shift and make it like 1, left shift c will make it 2 to the power c. Now -1 will make it, tell me the new number. So basically I need to store this new number inside the array first of all, and then also I need to do one thing. I need to store the difference. I need to store the difference between the two. So the difference will be nothing but the new number minus n, we can say. Okay, in the end we can simply say that we will return the answer. Let us see if it can get compiled, or we have made any mistake in this. Okay, so we are getting a compilation error. So it is saying 1 to the power c. Yeah, basically I should mark it as count here instead of c. So I should mark it as count. Let us see now what happens. So basically this step is nothing but dividing the number by 2. Basically if you do right shift by 1, so that is what we get. Okay, so in this case they are saying that we are not getting the right part, so we need to do here maybe n minus the new number, then we'll get it. Okay, now let us compile this. We are getting, okay, we are getting a different number. Like basically we are getting the same number as expected, but the ordering, first of all I have to store the difference, then I have to store the number. So first of all I'll store the difference, and then I have to store the new number. So I'll do what? I'll do it like n minus the new number. Now let us see. Okay, so yeah, so we have to do the new number minus n. So new number minus n. Now it will work fine, like n should be capital N. So let us see now what happens when we compile this code. So first of all we'll store the difference, and then we'll store the new number. So you can see that we are getting the same output. Let us try and submit this code. Okay, now talking about the time complexity of this code. So since we are using since we are dealing with bits, so the time complexity will be nothing but log of n for this particular problem, and the space complexity will be order of 1 because we are not using any extra space. In case if you understood the explanation, so make sure to write understood in the chat, and comment down understood in the chat, and make sure to like the video as well. Thank you.